I love my MacBook. Okay, here we go. Notes, applications of 2x2 systems of equations. Systems of equations can be applied to any problem situation which satisfies two criteria. Two unknowns can be identified and assigned variables. Two equations can be formulated using the variables. Okay, so 1. Teresa has a total of 40 DVDs in 2 categories. The number of her DVDs is 10 more than twice the number of her documentary DVDs. Determine a system of equations that can be used to find how many action DVDs, A, and how many documentary DVDs, D, Teresa has. So, what are our two variables? Let's identify those. That's the first thing it wants us to do. Anybody? Well, there's two different types, isn't there?
There's action and documentary.
There's action and there's documentary. So we have let A equal action DVDs and D equals documentary DVDs. Okay? What two equations can be formulated from the information in the problem using the variables? So what do we know? What have we been told?
That there is a total of 40.
Okay, so one equation could be just taking A plus D is equal to 40. Okay, what else do we know?
You would do the other one would be 10 equals
Well,
twice the number.
no, it says the number of action DVDs is 10 more. So the total number of action DVDs,
A equals
10 more than twice the number of her documentary DVDs. So twice the documentary, 10 more than. Remember, when it's a more than or less than, it comes after the variable. We've got to remember that, okay? So solve these systems of equations to find the number of action and documentary DVDs Teresa has. What is the most appropriate method to solve this system? So we have a single variable, don't we? So what do you think I'm going to use? Substitution. So I'm going to go to here and I'm going to do number 1, C. Okay? And I've got A plus D is equal to 40, and my other equation is A is equal to 2D plus 10. So which one is solved for a single variable already? The second one, right? So I've got this column, I've got this column, and I've got that column. So I'm going to put A is equal to 2D plus 10. And in the middle, I'm going to write A plus D is equal to 40. And then over here, I'm going to do A is equal to 2D plus 10. So I've already got it in single variable. So that makes this easy. I'm just going to take this part and substitute it in where I see A, because that's what A equals. So I'm going to write 2D plus 10 plus, I'm going to go ahead and put that 1 in front of my D so I make sure and remember that it's there, is equal to 40. Next step, combine like terms. 2D plus 1D is 3D plus 10 is equal to 40. Next step, subtract. Get my variables and my constants on the same side. I end up with 3D is equal to 30. And now I'm going to do what? Divide by 3, and I get D is equal to 10. Okay? So now that I know what D equals, that's my documentary DVDs, I need to find out how many action DVDs I have. So I can take my D and plug it in over here. So A is equal to 2 times 10 plus 10, and I get A is equal to 20 plus 10. Therefore, A is equal to 30. So I'm going to do a check. I'm going to go back to the easiest one to do. A plus D is equal to 40. And if I take and substitute action DVDs plus documentary DVDs, that equals 40, and 40 does equal 40. Therefore, I have a check. And if you notice, my action DVDs obviously are 2 times the documentary plus 10 would be 30, right? So I've got my action in my thing, so I can answer my question over here. So for number 1C, what is the, most appropriate? It says here, I'm going to say substitution. Solve the system of equations for the number of action and documentary. Action is 30 and documentary is equal to 10. Is the solution reasonable? Yes, because, and I guess I could have done my check over here. A plus D equals 40. 30 plus 10 is equal to 40, and 40 does equal 40. So I could have wrote on there C work number 1C, and wouldn't have to write that all there, but just so you know. So number 2. Everybody okay with what I just did?
Yes.
No big deal, right? Let X and Y represent the measures of the pair of supplementary angles. One angle is 36 degrees less than twice the second angle. What 2 equations can be formulated from the problem situation? First thing you have to have is the knowledge of what supplemental angles are. If I didn't know that at this point and I was sitting at home, what could I do to figure it out? I could Google it, couldn't I? Right? What's the measure of supplemental angles? Who knows what supplemental angles equal? Do any of you know? Lord have mercy. That was a 7th grade skill, people. 180 degrees. Okay? Now, this is a cheat I'll teach you. Okay? This is a cheat I'll teach you right here. If you notice C, okay, for complementary, all right, angles. This is a cheat. You should be able to memorize this one. C is very easily turned into 90 degrees, isn't it? Those are 2 angles that measure 90 degrees when combined. Supplementary angles. You guys were never taught this one? This little trick? Okay, look at the S in supplemental. What number can I turn that into? Really easily. An 8. So 180 degrees. So 2 angles that measure a total of 180 degrees. I know. I can't believe they never taught you that.
I knew that some of all the angles equal 180, but I just didn't know they were.
Not the sum of all angles. Supplementary angles are 2 angles. That's inside a triangle. That has nothing to do with this, okay? The sum of the 3 angles of a triangle do equal 180 degrees. That is correct. Complementary is just 2 angles that measure 90 degrees, all right? 2 angles when put together measure 90 degrees. Supplementary is 2 angles that when put together measure 180 degrees when totaled, okay? All right, so with that knowledge now, what 2 equations can be formulated from the problem situation? Does somebody want to try one? Okay, and I'm going to further define. Let X equal angle number 1. Let Y equal angle number 2. And yes, you're correct. X plus y is equal to 180 degrees. Okay? What is another formula that, or another equation we can come up with?
Y equals 2x minus 36.
Okay, the only reason I would choose y or x instead of y is because I named x as angle number 1, and it says one angle is 36 degrees less than twice the second angle. Do you see that? So just, I would imagine you'll get the same results, all right? But because for verbiage reasons, because I have already designated x is angle number 1 and y is angle number 2, then I need to make sure that x is equal, one angle is 36 degrees less than twice the second angle. So how am I going to write that?
2x equals 2y minus 36.
Minus 36. Remembering that less than means the number is going to come after the variable. Okay? Solve the system of equations to find the measures of the two supplementary angles. So I'm going to go back to my handy dandy piece of paper, and I'm going to put number 2, and I'm going to put B so that I can find this information easily. And I'm going to write my two equations down. I have x is equal to 2y minus 36, and I have x plus y is equal to 180. Now, what would you use to solve this? Substitution or elimination? Substitution, because I have a single variable, so it's easier, all right? So I'm going to put my single variable here. X is equal to 2y minus 36. Then I'm going to put x plus y is equal to 180. And then I'm going to put x is equal to 2y minus 36. I already have solved for x because it's already in single variable form, so I can take that and substitute it in where x is. I get 2y minus 36 plus, I'm going to go ahead and put that 1y there so I don't forget that it's a 1, is equal to 180. Same steps, combine like terms. 2y plus 1y is 3y minus 36 is equal to 180. I need to get my constants on one side, my variables on the other, so add 36 to both sides. I get 3y is equal to, well, what do I get here when I add that? 216. I'm going to divide both sides by 3, and I get y is equal to 72. Okay? Now I'm going to come over here and substitute in what my value of y is in over here, and I get x is equal to 2 times 72 minus 36. So I get x is equal to 144 minus 36. And when I take 144 minus 36, I get x is equal to 108. Okay? Now I'm going to do a check. So I'm going to come over here and do my check. X plus y is equal to 180. And I'm going to do 108 plus 72 is equal to 180. And I find that 180 is equal to 180. Therefore, I know I have the right solution. So I'm going to come over here on B, and I am going to write my solution of x, which is angle number 1, is equal to 108 degrees. Y, which is angle number 2, is 72 degrees. Questions? Yes, the hardest part is getting your two equations set up. But as you can see, these are not that difficult. They're pretty simple, aren't they? I hope you think they are anyways. And as you do them, the more you do them, the easier they will become. All right. Here we go. Two other types of problem situations that can be solved using systems of equations are rate and mixture problems. Set up two equations in the form of y equals mx plus b form. Manually solve the substitution. Calculator solve by graphing or a table. Green Grass Incorporated charges a flat rate of $15 per hour for lawn services. All right. So their main competition, S&G Lawn Care, charges an initial fee of $30 plus $10 per hour. These should be fairly simple. If I have 1 hour with green grass, how much does it cost me?
15.
So it's 15 times 1 hour costs me $15, doesn't it? 2 hours, so 15 times 2, if I fill out a process chart, is 30. 15 times 3 is 45. 15 times 4 is 60. 15 times 5 is 75. And I'm going to go ahead and do 6. I get 15 times 6 is 90. So what we're doing is the process is we're taking 15 times our x value, and that equals our y. Okay? So my equation here is y equals 15x. Okay? And they've given you a little thing to look at here. Okay? All right, so what is the process over here? So here it's 10 times 1 plus 30, which is equal to 40. 10 times 2 plus 30, which is equal to 50. 10 times 3 plus 30, which is equal to 60. 10 times 4 plus 30 is equal to 70. 10 times 5 plus 30 is equal to 80. 10 times 6 plus 30 is equal to 90. So here I'm doing 10 times x plus 30, and that means I have a y equals 10x plus 30 equation. What is x representing?
The number of hours.
Yes, x is representing number of hours. Okay, y is always your total cost, your total amount, whatever it might be, it is a total. Okay. Use the pattern in the table to write an algebraic expression to represent each equation. When they say expression, I want equation. An expression does not have an equal sign, so we've already wrote those. And we could do this. So we can identify them easily because we've got y in both situations, don't we? So instead of saying y equals, we've got green grass, so I could do g of x, or green grass, is equal to 15x. And then I have what? S and g, so I could use s of x is equal to 10x plus 30. You might just designate s is equal to 10x plus 30, and g is equal to 15x. But this way I know that that g of x means it's my y value, and this is my y value. I really don't have two different variables here. I just have two different costs. So if you were to just use g and s, it looks like you're solving for two different things, doesn't it? Okay, so this more identifies it as this is a function, okay? All right, extend the chart to find when the charges of each company are equal. Well, obviously I did that in the beginning. That's where you would do this. So find the system of graphically and algebraically. Well, let's see here. If I went graphically, I'd have to put it in my calculator, wouldn't I? Okay. Algebraically, how am I going to do that? No, algebraically means you're solving an algebraic equation.
Put them equal to each other.
So that's correct. Algebraically, we set them equal to each other, didn't we? So I'm going to use my paper and do 3c. And my two equations are g of x is equal to 15x. And here I have s of x is equal to 10x plus 30. Remember that we already figured it out with our table. This would be the same thing as putting your two equations in and looking at the table in your calculator. You could figure that out, okay? We already know the answer, but now they want us to represent it and show it algebraically. So I'm going to do 15x is equal to 10x plus 30. And I'm solving for the number of hours. After I solve for the number of hours, I can figure out the number of dollars, can't I? So I'm going to subtract 10x from both sides, get my variables and constants on opposite sides is equal to 30, divide by 5, and I get x is equal to 6. Now x, remember, represented what? The number of hours, okay? So they want to know the number of hours and the number of dollars, okay? Because it says for each, when the charges for each company are equal, at 6 hours, the charges are equal, but what are the charges? So I could pick either one. To me, it's easier just to do y is equal to 15x, and I do is equal to 15 times 6, which is my 90, isn't it? So I have solved those, so I could say here, I could say at 6 hours, which is $90, the cost is the same. Okay. Explain how to determine when it would be better to use Green Grass Incorporated and when it would be better to use the competitors of S&G and Lawn Care. What do you think? Isn't it? Okay, let's do it this way. Less than 6 hours, because they're asking for two things. Green grass is what? Is it more expensive, the same, cheaper? What do you got? Cheaper. Yeah. Okay. More than 6 hours. What's going to happen if I put 7 here? Or 6.5? 7 times that would be 70 plus 30, it would be 100, right? If you did 7 times 15, what would you get? 105. So more than 6 hours, S&G is cheaper. That answers that question, doesn't it? Okay. All right, last one. Mixture problem. Set up two equations in standard form. AX plus BY is equal to C. Manually, solve by elimination. We're not doing solve by matrices, so we're going to cross that out. Felix has a bug collection consisting of beetles and spiders. He has 75 bugs in all. Altogether, they have 26 legs. Identify the variables. So, what do we know? What are the variables?
Beetles and spiders.
Okay, so B is equal to beetles. S is equal to spiders. How about if we use B and S? Okay, write an equation representing the total number of bugs.
So,
What would I write?
75 equals B plus S.
Or you could do B plus S is equal to 75. Either way is, or you could write it B plus S is equal to 75. Either way, wherever you're more comfortable. Okay? Write an equation representing the total legs. Now what do I have? First off, you'd have to know how many legs are in a spider and how many legs are in a beetle, wouldn't you?
A spider has 8.
Do you know how many legs are in a beetle?
6.
Very good. You guys are on it. So,
You'd have to do
what can I do?
6b plus 8s is equal to 526.
526. Very good. And if you notice, they gave you an example. This is a beetle, so you could count the number of legs. And a spider, you could count the number of legs, couldn't you? Okay? I know. Right in front of your face and didn't even realize it. So, they said solve this by elimination. So, I have B plus S is equal to 75, don't I? And then I have 6B plus 8S is equal to 526. What do you think is going to be easiest to do?
Elimination.
All right, but what are you going to do elimination? You're going to have to eliminate either B or S.
It might be because it would be small.
Okay. So we're going to multiply every variable over here and every number by 6, aren't we?
Negative 6.
You want to do it by negative 6. Very good, because you have to get rid of it. So you'd end up with, all right, let's do it this way. 6b plus 8s is equal to 526. Now I'm going to do negative 6b minus 6s is equal to what? 6 times 75 is what? Negative 6 times 75.
300.
Nope.
Wait, no. 450.
Very good. Negative 450. Now, elimination. I love elimination. That goes away, doesn't it? Okay. 8s minus 6x equals what? 2s. And 526 subtract 450 is what?
76.
76 it is. So we are going to do what? Divide by 2. S is equal to what? 38. Very good. So I know that there is how many spiders?
38.
So we know that spiders equal 38. Now we got to figure out how many beetles, right? I think it's easier just to go back to B plus S is equal to 75.
You just do 75 minus. Like if you weren't doing it algebraically, you could do 75 minus 38.
You could, but you know what? Algebraically, dude. Algebraically. Hey? I know. So I've got B plus 38 is equal to 75. Subtract 38. And I get B is equal to, come on, little mathematicians out there, 37. So beetles. Now it didn't ask about legs, right? It just wanted to know how the number of spiders and beetles in the collection. If it had asked for legs, which one would I solved this correctly? I'd have to take this number, multiply it times 8, right? Okay, to figure out spiders, and I'd have to then figure out the number of beetles and take it and multiply it by 6 to find out or I could do it algebraically to solve for B. Okay? Do you see that? Everybody sees that. They asked for the number of spiders and beetles, not the number of legs.
I think his collection consists of bugs he just randomly found it outside.
Oh, you think so?
I couldn't do that because I feel like it would have to be like the now at the museum where all the like exhibits come alive. I feel like your videos and such are gonna kill you.
Oh, okay.